Hello, chemistry students. This is Mr. Suker, and we're going to review converting in SI units, formerly known as Le Système International, or more commonly the metric system. The great thing about working in metric units, which all scientists should, is that converting from one unit to another in a certain quantity is as simple as knowing powers of 10. So you can go from something like the meter, which is a standard quantity or standard unit in the quantity of distance or length. And so if you have kind of a normal length, you can use the meter. If you have something that's really long, you can throw a K in front of that. And now that prefix K makes it into a kilometer. So this would be a unit of a much larger distance. And then if we have something small, we can throw an M in front of it, and we can get a millimeter, which is a much smaller unit. But to convert between these, they're just powers of 10. And this is a common theme in metric units, that the letter by itself represents the metric unit, in this case meter for distance. When you see two letters, though, the first letter is going to be some sort of a prefix telling you how big the quantity is, and then the unit itself next to it. And this is pretty standard. There's some units where this isn't the case, but it's a pretty normal thing to see. The trick with SI units is making sure you know the prefixes, though, and how much they represent. And the way that this was normally taught was with something called the metric stairs or the metric ladder. And younger grades I take and I show students how to draw this. Let's see. There we go. And we'd adopt some sort of a catchy saying. The one on the PowerPoint here, King Henry drank both Duke's chocolate milk, where the B in both is for base, for the base unit. I've also seen it where you have a 0 or an O in the middle for no prefix, and you do something like kids have dropped over dead converting metrics. King Henry died of drinking chocolate milk. I've seen lots of different versions of them. You can have your own mnemonic if you want. I know my son had to make his own about for one of his science classes, and it had something to do with Kevin has donuts or something like that. I don't remember what it was, but so you'd have something to remember. King Henry drank both Duke's chocolate milk. So this would be the order of the prefixes. And then at the younger grade, you say, well, if you have a value, let's say you have something that's 5 meters and you want to convert it to millimeters, you would just move the decimal so many places to the right. So if we have 5 meters and I want to make it into millimeters, then I would just take this imaginary decimal and I go 1 step, 2 step, 3 steps, 5, 0, 0, 0 millimeters in 5 meters. The way we're going to use it is similar but slightly different, and I think we might be able to get past drawing the stairs unless you just really want to draw them. And the way we're going to do it is we're just going to kind of remember the prefixes. King Henry drank both Duke's chocolate milk. And basically any quantity that I put on here, let's say I need to know if I have, let's go with deciliters. So let's say I have a certain number of deciliters, and I want to know how many liters that has. So I want to know some sort of a ratio that I can put into a conversion factor. You could say 1 deciliter is how many liters, or 1 liter is how many deciliters. We know that we can reverse ratios like this and have them still be the same thing. The way I usually do this is I pick whichever quantity is larger. So in this case, liter is a larger quantity than deciliter. Deciliter is over here to the right. This is the small side. This is the large side. So what I will do is whichever quantity is larger, that becomes 1 liter. So on my little list here that I make in the margin of my test or on my worksheet or whatever it is, I'm going to put a 1 by that unit. In this case, it's the base liter by itself. And then I want to go to deciliters, so above each one I will put a 0 until I get to where I'm trying to end up. So in this case, deci is the next one over. So I get 10 deciliters is 1 liter. So I can put that in the form of a fractional conversion factor, 10 deciliters per 1 liter, or 1 liter per 10 deciliters, and then both of these are fractional conversion factors that I can plug into a dimensional analysis. So it's pretty simple to do this. The only thing that we have in addition to that, and you'll see it on the screen there, is if we go beyond the base prefixes, there are some other ones off to the side, over here and over here, that you see that are a lot of times computer terms. They talk about transistors in a microchip on the order of nanometers. We talk about storage on a hard drive of gigabytes or terabytes. The thing to know about mega, giga, and tera is that they are each 3 steps beyond the end of the main group of prefixes here. So if you're going to go to mega with the symbol capital M, there are 3 spaces in here. So if we have 1 megabyte, or let's say 1 megameter if we're dealing with things in space, and I want to get to kilo, I've got to put 1, 2, 3 zeros to get that. So if we switch over here and look at in a little bit more detail at these very large and very small prefixes, if we're at the left side of our normal prefixes, H, D, B, and so on, we can see from kilo to mega, we would have the 3 steps. And then from mega to giga, we'd have another 3 steps. And from giga to tera, we'd have another 3 steps. So what this shows us is that in 1 terabyte, or 1 terameter, or terasecond, or tera whatever you would want to measure in, to get to giga, I would go 1, 2, 3 steps. So 1,000 gigabytes in 1 terabyte. And then to go from giga to mega, I would have to add another 3 zeros. So a megabyte is a million, or excuse me, a terabyte is 1,000,000 megabytes. And then if I go another 3 steps to kilo, 1 terabyte is a billion kilobytes. And that's kind of funny when I think back through time at how many kilobytes of memory my first computer had. And I think first floppy disk I ever used stored 1/2 a megabyte of information on it, and now you can go to Staples or Best Buy or anything and buy hard drives that store several terabytes worth of information. So in the last so many years, the amount of storage and memory capacity of computers has gone up a ton. On the other end of the scale, milli to micro to nano to pico is the same way. If we have 1 millisecond or millimeter or anything like that, 3 steps in between milli and micro, so 1, 2, 3 microseconds in a millisecond, 1,000,000 nanoseconds in a millisecond, and 1,000,000,000 picoseconds in a millisecond. So, and if you want to go between these 3, say you have 1 microsecond, how many nanoseconds is that? That would be 1,000. So with all of our other prefixes, it is 1 step between each one. With these very large, very small prefixes off to the side of the PowerPoint there, it's 3 steps each. Underlined on all of those Prefixes are the symbol, so capital T for tera, capital G for giga on around. Notice that micro is the only one that's a little bit funny. We have the Greek letter lowercase mu, which looks like a backwards Y, because M was already in use for milli. And anytime we run out of regular letters, we go to Greek letters, so micro gets the Greek letter lowercase mu. So if we were to talk about microseconds, this would be a how you would write the symbol for microseconds. So the backwards Y, the mu, and the S for seconds, microseconds. So if we were to want to convert that to milliseconds, then we would be at milli, we'd put a 1, we'd go over 3 steps for 1,000, so 1,000 microseconds in a millisecond. So let's take a look at a sample problem of how this would work. So we have a question here. How many moles of iron 3 oxide are in 27.1 kilograms? If we're going to solve this, we know that we have a tool for getting from mass to moles of molar mass. And we've used this one before. So, we'd start to set this up. You'd, identify your unknown. You'd identify what you have. And we'd say, okay, I know how to do this. I'm going to take 27.1 kilograms, set it over 1. And then I'm going to want to take a mass and use my molar mass. So, if I want moles on the top, I want grams on the bottom. I plug in my number, which I got from webqc.org, 159.69 grams in 1 mole. And I'm going to look to cancel, and I cannot get to moles with this because kilograms and grams do not cancel. So what I need to do is add in another multiplier right here. It is my conversion factor from grams to kilograms. So if I go through my prefixes, kilo, hecto, deca, base, deci, centi, milli, I'm wanting to get from kilograms to grams. So I go with my larger quantity. 1 kilogram is 1,000 grams. So now when I do the dimensional analysis, kilograms cancel, grams cancel, moles is what's left. I do the math, multiply across the top, divide across the bottom. My calculator is going to spit out 16.9710380111147, but 16.97 to 3 significant figures comes out to be 17.0 moles. So we use some sort of a arrangement of the prefixes. We remember those with some sort of a mnemonic. We get fractional conversion factors out of that, and they just become another little multiplier that we plug into dimensional analyses when we need to get the units to work out. And if all you're doing is a unit conversion, you'll just have your quantity, you'll have your conversion factor, you'll get your answer, and you'll know that you've divided or multiplied correctly when you should have. A lot of our units are going to be from base to kilo or base to milli. There's certain ones we'll use more often than others. You'll get more natural out of them the more you do it. But until you get really proficient at knowing the prefixes, you may have to scribble something like this in the margins so that you can generate these little fractional conversion factors later on. Hope this helps. See me if you have questions. We'll be practicing this throughout the rest of the unit. Until then, take care.